Okay, so hello everyone, welcome. Can you hear me? Okay, so you're waiting 1 or 2 minutes for joining all of those other participants, then we'll start. So in the meantime, I also give you an announcement for our upcoming online training program. So mainly this class will be start from the 10th February and it also total 7 days online training program. And you can first 10 registered people will get the 50% discount on this online training program. So basically, it's a totally 7 days online training program for the beginners who don't have any knowledge about that Google Earth Engine or machine learning. So I hope after completing the total 7 days online training program, you are able to do any types of remote sensing analysis very quickly and efficiently using Google Earth Engine platform. So you can get all of those course content. I already added all of those course content in the video description. You can simply check all of those course content and further you can easily join. Okay, and you also get this type of benefit. You can get the course certificate, all of those material slide PDF. You will get all of those practice code, also get the recorded class. When you if you miss any live trading session, you can easily cover using the recorded class, as well as you will also get the lifetime teaching support. It's very important as a beginners. When you want to learn the Google Earth Engine platform, you face a lot of problem. So that's why you also get the lifetime teaching guide. So further you can easily learn all of those things in Google Earth Engine platform. Okay, and if you want to join this online training program, you can simply contact in this WhatsApp number, or if you want you can also contact with this email for further registration and book your seat and then join in our Google Classroom and further join in the live training session. Thank you. Okay, so now we will start today's session. So basically today I will try to discuss about the machine learning, how we can easily implement the machine learning using Google Earth Engine platform. So different types of machine learning such as supervised, unsupervised, how we can easily apply using Google Earth Engine platform, and then use the different types of work such as land use, land cover classification, or other types of machine learning work, how we can easily handle using the Google Earth Engine platform. Okay, so let's go. Just I simply share my screen. Okay, so now can you see my screen? Visible? Okay. Okay. So today I will try to discuss about this topic. So mainly introduction to machine learning in Google Earth Engine. Then how we can easily make the land use land cover mapping using machine learning. We talk about the supervised as well as also unsupervised algorithm. How we can easily apply, as well as how we can easily apply the different types of uh, supervised learning, such as random forest, then classification and regression trees, then support vector machine, then minimum distance. So this type of classifier, how we can easily use and then make the land use land cover classification. Then how to check the land use land cover accuracy assessment, mainly the overall accuracy, kappa accuracy, producer accuracy, consumer accuracy, how you can easily calculate using Google Earth Engine platform. After that, calculate land use land cover classes area, such as how much built up area, how much vegetation, okay, this type of things, and how to add the legend in land use land cover map in Google Earth Engine platform. After that, how to export this map in as a TIFF format, and further you make the map using ArcMap software. Okay, so let's go about this topic. So I simply share, open my slide. Yeah. So machine learning in Earth Engine. So basically, in this time, in Google Earth Engine platform, we can get some built-in function. Okay, so as we can easily get the random forest classification trees, and also other built-in function we can easily use, and then apply the different types of machine learning algorithm such as supervised, unsupervised, random forest, or other types of algorithm we can easily apply. Okay, so basically in this time we can get three types of uh, such as supervised classification. We can use the Google Earth Engine platform, unsupervised, and regression. So now I talk about the supervised. So basically, supervised classification method or machine learning technique, when you want to do, you must need the training sample. Okay. Suppose you want to make the land use land cover classification map using supervised classification. You must need the training sample. Supervised classification, you must need the training sample or your ground truth data or pre-categorized data. You must need. But when you want to work for the unsupervised classification, no need any kind of ground truth data or any kind of pre-categorized data, don't need, or any kind of label data, we don't need for the unsupervised classification. But supervised classification, you must need the ground truth data or your label data or pre-categorized data. So basically, this is the basic difference about the supervised and unsupervised. So when you want to apply the supervised machine learning algorithm, we must take the training sample and create the pre-categorized data. And unsupervised learning, we don't need any kind of training sample. Okay. So basically, this unsupervised learning, it mainly work for the clustering. Clustering mainly, this algorithm find out the similarities pixel value and automatically classified without any kind of training sample. Okay. So further discuss about the practical example, then it also better. And regression, mainly this regression, it's a classification model, and it just find out the different types of future happened, such as regression model could predict water quality, then percent forest cover, present cloud cover or crow field. So these type of things we are also apply the different types of linear regression. Okay, so these type of things we are also apply, and we can easily find out the suppose vegetation trend, different things we can easily do using the regression. So basically, machine learning in Google Earth Engine platform, we can apply the supervised, unsupervised, and regression. Three types of learning we can apply, as well as if you want, you can also apply the suppose some deep learning, such as CNN, convolution neural network. It's also possible to use the Google Earth Engine platform, but it's not free. But when you want to apply the CNN or RNN, this type of deep learning things, then we have to pay the Google Earth Engine platform, or we need to buy the commercially use. So here you can see a website. Okay, just I show you that. Suppose, yeah, can I already open it? In this time here you can see mainly when you want to apply the artificial intelligence, different types of models, such as you can see CNN, and also suppose you can see the TensorFlow. Okay, for the deep learning, DNN, okay, deep neural network. Also you can see when you want to use these things, then you have to use their Google Cloud. Okay, you need to buy, and then you have to use this, and they already provide some demo code about that. You can see, you can simply click on here, it automatically open this demo code. But when you want to work this demo code, you have to buy the Google Cloud. Okay, and you can easily buy it. Basically, when you apply the CNN or DNN, these type of things, or TensorFlow, these type of things, then we have to buy their cloud things from here. Also, you can see there, you can this guide use basically components of Google Earth Engine cloud, including Vertex AI, cloud storage, Earth Engine. So you can easily price calculator to generate cost estimate based on your project. Okay, so you can buy, and then they already provide some demo code. Okay, and also suppose you can see, okay, there you can see they already provide some demo code about that, how we can easily work. Just you have to put your project ID, your region, your model name. Okay, code is the same. Okay, in this time you just simply put your project ID. So basically, when you want to buy their cloud project, they are automatically they provide you the project ID, You can simply put your region and your model which you want to need, CNN or DNN or which one you need. You can simply put this model name, then automatically it predict or it automatically apply the CNN or this type of things automatically apply. Okay, train your model, all of those things automatically show you. You can see that already provide some demo code about that. Okay, but for using these things, CNN or RNN, we have to buy their cloud project and then work with that. Okay, but for the machine learning, when you want to use this type of machine learning such as random forest, then also use the suppose other types of machine learning, supervised and unsupervised machine learning is totally free of cost. We can easily apply. But when I want to apply the deep learning using the TensorFlow, CNN or DNN, these type of things we have to pay. Okay, so I also send you this link. You also try to check about that. Okay, and you can easily price calculator to generate your estimate project. Okay, you can see, and you can easily make this payment using the your MasterCard or Visa card, and you can easily work with that. Okay, so in this time, you can simply go all of those things from here. You can see all of those demo code for the CNN or DNN. You can easily access from here. Okay, just you have to buy, and then you can define your project ID and which algorithm you want to need. You can simply put this name, then automatically. And when you want to buy this, they are also provide you a user manual. Just follow this user manual, and you can easily do that. This type of deep learning you can easily apply. Okay. So in this time, we are not focusing in here. We are just talking about the free of cost machine learning method. Okay, and we can easily apply the different types of supervised and unsupervised machine learning model in Google Earth Engine platform free of cost. Okay, so now let's check about this type of model which we can easily use the freely in Google Earth Engine platform. So basically, in this time, we are use here the different supervised machine learning model. We have used some classifier. Okay, mainly classifier is one kind of algorithm. Okay, suppose what is classifier? Mainly the algorithm which implement the classification on a data set is known as a classifier. Suppose I have a data set, I create a data set. So now this data set I want to apply a method, okay, or algorithm. This algorithm called one kind of classifier. Okay, so in this time, mainly we can get the two types of classifier. Okay, one is the binary classifier, another is the multi-class classifier. So now mainly binary classifier, when you can get the classification problem provided only for the two possible outcome. Suppose I just make the classification yes or no, male or female, spam or not spam, cat or dog. The outcome result I can get only for the two outcome result, two possible outcome we can get. It is a binary classifier. So binary classifier, also you can see the multi-class classifier. Multi-class classifier mainly when we can get the result more than two outcome. Okay, suppose land use land cover classification. I want to classify, suppose build up area, settlement, vegetation, water body, cropland. So it's a multi-class, as well as classification of types of music, classification types of crop. So it's a multi-class classifier. For the binary classifier, we use this type of algorithm such as support vector machine. Okay, mainly binary classifier. When you want to suppose you classified only for the two class, so then you can easily use here the support vector machine. It worked very well for the binary classifier. Suppose multi-class classifier, you can easily apply the random forest classifier or classification or regression trees, and you can easily classify it. Okay, so further we discuss about that. And now in this time, I try to discuss about that how we can easily make the land use land cover classification map using machine learning. Basically, I will show you that two types of machine learning, supervised and unsupervised. Okay, so supervised learning, we must need take the ground truth data. Okay, or we need to create the pre-categorized data. Okay, and how we can easily create the pre-categorized data. Further, I try to show you that one by one. So first of all, we try to discuss about what is the process to make the land cover classification map in Google Earth Engine platform for supervised. Okay, first try to discuss about the supervised, then show you the unsupervised. So when you want to make the map using unsupervised classification, supervised classification, First of all, you have to selecting your study area. Okay, suppose you select your study area. Suppose my study area is the Dhaka city. I select my study area in my Dhaka city. Second step, you choose and filtering your image collection. If you want, you can use there the Lancet, or if you want, you can also use there the Sentinel. No problem. Just choose and filter your image collection according to your region, according to your cloud cover, according to your time period. Just filter your image collection. Okay. After that, it's a supervised classification. For that, you must take the training point. Okay. So in this time, how I can collect the training point? So there are a lot of way for collecting the training point. If you want, you can physically visit your study area and take the GPS location, and then you can use it as a training point. Or if you want, you can use there the different types of band combination, and then collect the training point from the satellite images. Okay, so it's another way. Suppose you physically visit your area, you can simply take the some GPS location, mainly coordinate or longitude and latitude. Then further, we can easily import these things in Google Earth Engine platform and use it as a training point or training sample. Or if you want, you can also use the different types of band combination and take the training point from this satellite images. This is the water, this is the vegetation, this is the build-up area. Just take the some training point. So it is the another way to collecting the training point. After getting the training point, you just merge all of those training point. Simply merge all of those training point in a one variable. Okay. Now, after merge all of those training point, we have to create the data set. Basically, this data set, it's stored the different types of spectral signature. Okay. So it's suppose I take the training point for water. So all of those water point extract the information, mainly bands information or bands spectral signature extract from here, and then make the spectral signature for water. Suppose I take the some training point for build up area. So it extract the information, mainly bands information or spectral bands, spectral signature extract from the build up area and create a data set. Okay. So now we create this data set. So in this time, after creating this data set we have to split into two. Suppose in this time, if you want, you can use the 70% data to train your model and 30% data to test your model. Okay. So after making this training data set, we are just split. Okay. Suppose 70% data or 30% data, 80% data or 20% data. 80% data I want to use train my model, and 20% data I use for check the validation about this model. So just we split these things. Then 70% data I use and make a classifier. So in this time, after getting this data, suppose 70% data I use in my classifier. Okay, and make this model and further classify this image and then create this classified image and then display this result. In this time, rest of the 20% data I use and then check the validation. I check the using the confusion matrix table I create, and further we are just check about the accuracy assessment, different types of accuracy assessment such as kappa or producer accuracy or consumer accuracy. We can check. Further we are just simply calculate the area and then export this map as a TIFF format. So basically this is the simple process to make the land use land cover classification map using supervised machine learning model. Okay. So any question you can ask me, anyone. Any question? Okay. Yes. Yes, easily we can do it, no problem. Okay. Suppose we can observe a spectra from the particular mineral or vegetation types as a training point, and further you can use it. If you want, you can also make the classification using this spectra, as well as you can easily use the different types of band ratio. Okay, and then you can easily extract the specific class. It can be mineral or vegetation or anything. Okay.
This can be done using spectral library.
Yes. But in this time, a spectral library, it's I think it also available for the R programming. But in Google Earth Engine platform, we can easily extract the information, or we can easily get this type of spectra as a data set. We can easily store it for a specific point, and further we use it and then make the classification and other things we can do. Yeah, okay, it is possible. Okay, so in this time, okay, so let's check the practical example also better. Just I simply open my code editor. Okay, so in this time, first of all, I just simply import my study area. Okay, um, just click on the asset tab, and suppose I want to work for that specific city. Suppose, okay, so I want to work for the suppose Dhaka city. Simply import, and you can see it imported. Default name is a table. I simply change it as a RY, and then I just simply display this layer map.add layer, this RY, and further I simply show this map.center view of this study area, and put here this RY, zoom level suppose 10, and just click run. So now this is my study area. So now I need to filter the image collection. Okay, we already show you a lot of process for filtering the image collection, Landsat or Sentinel. So anyone you can choose and then filter. In this time, suppose I want to use here, suppose Sentinel, two satellite imagery I want to use, and further show you this process. So simply click on the Sentinel, and if you want, you can also apply the same process for Landsat, no problem. Okay, so I simply click on here and then click the multi-spectral instrument level 2, Sentinel 2. And from here I want to use for the surface reflectance. So basically it's better to use for land use land cover classification. Okay, just I simply copy these things from here and then paste, and then give a variable name and store it in here. So just I put a variable name, suppose image. Okay, so further we are just simply same process we shall show you the already about that for filtering. Suppose I put here the filter bounds for intersecting with our study area, mainly RY. Then put here the suppose filter metadata for image properties. I want to choose for the cloud pixel percentage less than 1. So I simply copy here cloud pixel percentage, and further put here this less than suppose 1. Okay, and further after doing this, I suppose I want to make this map for a specific time period, filter date. If you want, you can put any time period. I want to make this map, suppose year of 2020. Suppose, okay, I make the map 2020, 1st January from 2020. Suppose December 31. In this time, I want to make the median composite. If you want, you can also take the single image or anything you can put. Suppose I take the median composite. So just use here the median, and then further clip with my study area. Mainly it's a RY. So now show this image map dot add layer, and call this image and click run. So now it loaded this image. So we can get this type of image. Now simply click on here. Here you can see I can get this type of value. You can see it's very long value. Okay, suppose I click the 98% stretch. It show this type of value 605 120. In this time, this spectra is not the reprojected this scale value. This band's pixel value is not reprojected. So for that, I just simply can see they already provide some bands scale. Okay, so all of those band is the same scale. You can see 0.010. So just I simply copy these things from here, because all of those is the same, okay, scale value. And I just simply put here a function multiply this value. Okay, so now we can get the proper spectra from here, value range. So now it will work, and I check it from here. Suppose click on here, and now I just simply set the band combination. Suppose red, then green, and blue. And further, suppose 98% A stress. So now we can see reflectance 0.06, 0.1. So this range. So because I multiply with reprojected these band values. Okay. So now further apply. So now I can get this type of image and then import. Suppose I import these things from here. So that's why it will be set with my code. Simply copy this variable name and paste after the object. So now this is my image. Okay. So this is my second step is done. Okay. First step, selecting your boundary area. Second step, you would just simply filter your image collection. Okay. And display your image. In this time, third step. In this third step, we are collecting the training sample. Okay. And there's a lot of way. If you want, you can use the different types of band ratio, and you can easily find out some specific feature. So basically, for the mineral exploration, we are using the different types of band ratio. Okay, you can see the different types of journal or paper. They use the different types of band ratio, and when you are use this band ratio, then some specific mineral it's reflected. Okay, and from here we can easily get the idea about that. Okay, so and from here, if you want, suppose you are using the some specific band ratio, and from here you can just simply collect the training sample. Suppose it's the iron oxide. Yeah, you can take the training sample. It's iron oxide, and you can easily take it. So in this time, we are not talking about the mineral exploration. We are just talking about the land use land cover classification map. And from this image, I want to classify it, suppose water body. I want to classify it, as well as also build up area. I want to classify it, suppose barren land, and suppose vegetation. Okay. So in this time, I need the training sample for build up area, water body, vegetation, water and barren land. Okay. So the 4 class I need for that. Okay. Training sample. So now how I can collect the training sample. So if you have physically visit the ground and take the GPS location, it also okay. There is no problem. Or if you want, you can also use here the different types of band combination. Okay. Suppose in this time, it's called the natural color band combination. Okay. So mainly RGB, red, green, and blue. Okay. So when you put here the RGB color, then we can get this type of feature, mainly natural feature we can get. And naturally, we can easily identify. You can see this is the water body. We can easily identify, and we can get the naturally vegetation as a green color. We can get from here. It's a green color. We can get this is the build up area or settlement. We can easily get from here. Okay. But suppose in this time I want to use the another band combination, such as I set the band combination, such as suppose near infrared band, mainly for Sentinel B8 near infrared. Then put here suppose red band, and put here the suppose green band. Okay, and further just increase it to 98%, and then apply. When I use this band combination, then I can get this type of image. You can see it show the vegetation as a red color, water body so as a black color or dark color. Okay, so you can see from when I use this band combination for any region. If you want, you can also apply the Lancet also. Suppose you put here the near infrared, then red and green. Then we can get the vegetation as this type of red color. Okay, better vegetation have better red color. Okay, and we can get this type of water as a you can see black color or dark color. We can get the water body as a dark color. So it's a one kind of band combination. When you want to use this band combination, near infrared, red and green, then I can get this type of feature. Vegetation will be shown as a red color, water body show as a black color or dark color. Okay, so it's the one, another kind of band combination. And suppose I want to use the another band combination, mainly it's called the short wave infrared one. Short wave infrared one mainly for it's for Sentinel B11, short wave infrared one, and then set here the near infrared. pH, and then set here the suppose it's a blue, and then and 8% and apply. So in this time here you can say I can get another band combination, and from this band combination you can easily identify the barren land, vegetation, water body. You can see in this time we can easily identify this is the barren land. You can see this type of color identify about the barren land, gray color. It's a barren land. And we also get two types of barren land. One can we can see about that mainly wetland, and we can see this type of things identify about that barren land. We can easily identify it's a barren land or fallow land about that. Okay, and we also get about these things. You can see the vegetation about that things. Okay, we can get the water body. This is the black color. Okay, when I use this band combination, we can easily identify this type of things. So in this time, if you don't physically visited your study area, then you can easily apply this type of band combination and collect the training point or training sample. So now this is my satellite image. I want to collect the some training sample. Okay. So how I can collect? Very easy. In this time, you can see here marker. Click on the marker, and then suppose you can see it added the geometry. So click on here, and I put this name. Suppose I give this name as a suppose water. I take the training sample for water. To put the name water and imported feature collection and set the property. Property you can put any name. Suppose I put the name is a class. Okay, you can put any name and set the water for suppose 0. Okay, it's a value. So first of all, provide the name. You can put any name as a variable, and then import feature mainly property class and set the value 0. Then click to the OK. So you can see water, it's selected, and then you can simply click on the water body. It's the water. So just simply take the same from your satellite image, just simply click and take this training sample. Okay. Basically, we are applying the supervised classification. So that's why we must need the pre-categorized data. And in this time, I just take this training sample and I call this is the water. Okay. So further, it struck the it's make the spectral signature for water body. Okay, and try to find out the other place. If this spectral signature is the same, then it automatically predict it's a water body. Okay, so in this time I simply take the same sample from here. And how much training sample you can get take for each classes? So basically, you try to take more training sample. Okay, and basically when you want to take the more training sample, then it more correctly classified. Okay, and in this time, suppose I take the 33 point for this water body training sample. Okay, it also okay, there is no problem. And if you check your accuracy, suppose you can get the very low accuracy for your classification, then you are just increasing the training sample again. In Google Earth Engine platform, we can easily increase the training sample easily, and then we also check about the accuracy. Suppose I can get the very bad accuracy, so then we are also increasing the training sample of each classes, and then check what's happened now. Okay, so suppose I take this training sample for water, and further I take the training sample for other class, suppose barren land. So just take the new layer and click on here again, and now I put this name, suppose barren land, and then further imported feature collection and set the property name always same class. In this time I set the value for 1. Okay, 0 then 1. So in this time you can see it's a 0 then 1. So now select the barren land and then simply take this some training sample for barren land. So just I simply click on here. In this time I just also take the wetland and barren land as a one class. So just I use the same. Okay. And if you any wrong interpret, so further click on the exit and then simply click on here and you can see delete it. Okay, simply delete this training sample, or you can easily move this training sample for your proper place. That was I just moving here. Okay, so now Barrelland done. So I want to take this training sample for vegetation. Okay, for that I just click on here again, new layer, and then click on here and then put this name as a vegetation, and further feature collection again, and property, set the property for class and value for 2. Okay, then okay. So now you can simply take this type of green pixel. So just simply take this training sample for vegetation. Okay, so I take the same template for vegetation, and finally suppose I take this turning point for that build up or settlement build up, and further just feature collection again, property, set the for class and for 0 1 2 3. So first of all, then 0, then 1, then 2, and then 3. Okay. So now you'll just simply take this training sample for parallel, and you can simply check it from here. Suppose you can easily use the different types of band combinations. So I do change it. Suppose I check the red, then suppose green and blue, and then apply. So now we can get the natural color. So here check the different types of pen combination and then take the training sample. And now further you can see I simply take this training sample from here. They build up. So now take the same training sample for the build up region. So take this training sample for build up. Okay, suppose I take this training sample of the build up area. Okay. So now after getting this training sample for all of classes, you would just merge. You can see it also added this type of feature. You can see water, barrel land, vegetation, build up. It's added in here. Okay. So in this time, I just need to merge all of those training sample together. So now how I can merge? Very easy. Just you can simply, so mainly it's your third step. So mainly you are just take the training sample. And for this step, we are just merge. For merging, just take a variable. Suppose I put the variable name is that samples, and then call all of those variables. Suppose water, then put here the merge with suppose barrel land, then merge with suppose vegetation, then it merge with build up. Okay, just use the same name. And now you can check, suppose I print that, so print this samples and click the run. In this time it show about that how much training sample I take for all of those classes. So you can see the total, it we take 152 classes. Okay, 152 training point for all of classes. Okay, so further click on here, you can check, suppose click on here, you can get, you can see all of this point. Okay, from 0 to 151. Okay, total 152 points we can take, and we already set the label. Suppose this point, what's the label about that, you can see this label is for class 1. Okay, so this 50 number training point, its class is the 1. What is the 1? 1 is mainly barren land. Okay, suppose you check the other class, suppose this class, what is the label about that, you can see this label is the class 3. So class 3 mainly it's the build up. Okay, so it's called the pre-categorize. Okay, so I already categorize, this is this is the water, this is the build up, this is the vegetation, I already categorize. So in this time I just make the sum band. Okay, suppose I want to extract the sum band's pixel value or a spectra, I want to extract from here. Suppose this point, suppose this suppose it's a single point. For this single point I extract the pixel value, some band's pixel value. If you want, you can also NDVI, NDWI, or anything, or any band ratio you can apply and extract the spectra from here easily. Suppose in this time I just make a list. Suppose I just take a variable, put the variable name, suppose bands, and then I put all of those bands, which band I want to extract the pixel value or spectra and extract from here. So here you can see, so mainly in this time I want to use here, extract from here the 10 and 20 meter. Okay, so this type of band I want to use in here. So 10 is mainly B2, B3, B4, B5, B6, B7, B8, B8A, then B11 and B12 I want to use. Okay, so in this time I just make a list about that. Okay, so B2, B3, B4 I simply put in here as a list. So first of all B2, then B3, B4, B5, B6, B7, B8, then B8A, then B11 and B12. Okay, so in this time I simply put here, you can see B8, B8A, and take that B11 and B12, short of 25 and short of 22. So now further in this time I want to extract this pixel value or spectra for each single point. Okay, so now how I can extract this pixel value from here? Very easy. We already discussed about a function. So mainly this function called the sample regions. So you can see sample regions. So basically this function we are use. So basically in this time convert is pixel of an image. So in this time you can see you need a collection. Okay, so you need a collection, then need a properties, then a scale, projection, tile scale. So then we can easily use this function and extract the pixel value of each pixel of an image. So for that I just take a variable. Suppose I put the variable name is that training. You can put a name. In this time I already in this variable image. So this variable mainly stored my satellite image. Okay, so just I simply copy and paste here, and then use a function, select function, and select all of those band. Okay, so it is stored in here. Simply copy and paste, and then use this function sample regions. Okay, So basically this function extract the pixel of. So now I put all of those things, just I make a dictionary. So curly bracket start and also curly bracket int. Okay. So further put at the collection. In this time, I have total 152 points. I already create. Okay. I already create 152 points and it is stored in the samples. Simply copy and paste here. It's my collection. Properties. Properties mainly it's my property name. Here you can see the water barrel and I already put the property name. You can see property name mainly class. I use the same property for all of classes. Class. Simply copy this property and here you can see the properties. So it's a plural form. Okay. So that's why we must use here the square bracket. Okay. It's a plural form. So use here the square bracket and then put here the property name class. Scale. Scale is the resolution. So in this time, I just put here the 10 meter and projection. I simply remove that. It's not needed in this time. So now further, I just simply print this training and paste here and click to the run. In this time, all of those point extract all of those bands values for each single point. Okay, so here you can see, just click on here, you can see feature and you can see all of those training samples. Suppose click on here 19 and you can see it extract the all of those band below B1, B11, B short wave infrared, short wave 2, all of those blue, green, red, near infrared. So all of those things extract from here. You can see. Okay. And also you can see what is the class. Class is the 0. Okay. So I already make the pre-categorize about that. Suppose check the another 64. Here you can see it extract all of those bands values of this point. And what is the level? Level is class 1. What is the class 1? Class 1 is for parent land. So check all of those things. You can see all of this. So it's my data set. Okay. So further, I use this data set and then classification and also check the accuracy. All of those things I want to use this data set. So this is my data set. So in this time, I create my data set. Every single point you can see extract all of those band values as well as also show their label. Label is 2. So what is the 2? 2 is mainly vegetation because you can see when I put that, I put the value is the 2. Okay, you can see. Suppose you can see this is that. Okay. So basically this is the process. So in this time I get my data set. So now I can easily apply the machine learning. So now this data set I want to split into two ways. Suppose from here, basically it's a common characteristics of machine learning. Mainly when you want to do some data set we are used to train our model and some data set we are used for check our validation. So basically in this time different paper you can check. There are also some paper you can check that use at the 70% suppose 70% data to train their model. Okay, suppose train their model and suppose 30% data they are used for check the testing or check the validation. Okay, some people also said they are used at the 80% for train their model and 20% data for testing. Okay, so it's the ratio. You can easily use anyone, no problem. So in this time for my model I want to use at the 80% data to train my model and 20% data for check my validation. Okay, so let's go how I can spill this data set. Okay, it's very important. And this my full data set training. This variable stored my full data set. Okay, so now this data set I want to spill in the two way, 80% and 20%, and I want to do it randomly. Okay, suppose randomly it selected 80% and 20%. So in this time this data set I want to make the randomly distribution. Okay, so how I can randomly distribution this data set? Very easy, just take a variable, suppose data set and call your full data set, basically training. This variable is stored your full data set. So simply copy and paste here, and then use a function random column. Okay, so basically this data set distribute your data randomly, random column. So now further I simply print that and then check what happened. I check it, suppose data set, and click run. So here you can see we can get the one column feature. Okay, guess randomly we can put in here. So it show the random. You can see. So in this time from here, so this is my final data set. Suppose after put the random column, I just spill this data set. Okay, so two way. So first of all, suppose 80% data I want to use for train my model. Okay, train. So the spill it, suppose take a variable. Suppose put this variable name is the train set, and further call this data set. So now I filtered this data set in 80%. So just put a function filter, then use our art engine dot filter. First of all, filter getter, then random 0.8. Okay, and take the another variable for test set. So test set, then call this data set, its filter mainly art engine dot filter, in this time less than equal random rest of the other data set mainly 0.8. Okay, so in this time I spilled this data set, this is my full data set 100%. Then further I take this greater than all of those 0.8, and
It
also
should be
take
point two.
yeah, oh yeah, yes, okay. Okay, so in this time we are just simply spill this data set. Okay, so now further in this time I just simply use this variable train set. I use it for train my model, and this variable test set I want to use it for check my validation. Okay, so now in this time we talk about the model. In Google Earth Engine platform, there the lot of model is available. You can see simply search here. Suppose ee dot search here classifier. Here you can see there are a lot of model. Okay, in this time basically this type of model is free of cost. There is no charge for that, because in this time this type of model mainly it's the built-in function. Okay, so in this time they are just use this function. When I use this function and train my model, it will be okay, there is no problem. But when you want to apply the CNN or RNN or DNN, then this type of things we have to buy. In this time that is not free of cost, we can easily use it. So here you can see the different types of model. So one model is that you can see it's the support vector machine model. About that, just how I can use it, simply copy this function and then we can easily use it. There is no need to other types of things in this time, no need, and it will be work. As well as the classification regression trees, okay. Also you can see about that KNN, you can see this model, K nearest neighbor algorithm. Also you can see random forest, okay, you can see random forest algorithm about that. So in this time you can choose any one algorithm. Okay, suppose I want to choose, suppose random forest, simply copy and then paste. Suppose I create the model. In this time we just create a model, so just paste here. Okay, and in this time just take a variable. Suppose I put the variable name is that model. Okay, I put this variable name as the model. In this time this model, you can see this type of argument, number of trees per. In this time it's very important for the number of trees. Okay, And this number of trees also depend on your accuracy. Okay, and number of trees we can easily calculate. Okay, and this number of trees, so basically this value is not fixed. Okay, we need to calculate this number of trees values. Okay, and then find out the best number, which number is best for my model. I need to find out it. So there are a lot of way to find out this number. So okay, so it's called the hyperparameter tuning. Hyperparameter tuning we are use basically this hyperparameter tuning is the best number for this model. Okay, so further class I will discuss about that hyperparameter tuning, how we can easily find out the best number of trees and then use it to develop our accuracy. So in this time I just put the one value, suppose 150. Okay, but this value is not fixed. Okay, this value is not fixed because hyperparameter tuning is the different for a specific region. So that's why I also try to discuss about the further class how we can easily find out the hyperparameter tuning. So in the meantime I just take the one random value 150. Okay, so then I simply remove that, it's not needed in this time. Suppose I put the decision number is the 150, but it's not fixed. It has the another way to find out the best number of trees, and it's called the hyperparameter tuning. Okay, so now this is my algorithm. I want to train it. So just use a function, train function, and I want to train it with my 80% data. Okay, I already split it. So just simply make a dictionary, curly bracket start, and also curly bracket int. So further put here the feature. In this time my feature is mainly 80% data. Train set, simply copy and paste. Class property. Class property mainly your property name. Here you can say I already make the property name for the class, and it's a singular form, property. Okay, don't need use the square bracket, just put here the class. Input properties, you can see properties, it's a plural form. Okay, so basically when you can get this type of argument properties plural form, you must use the square bracket. And in this time input properties, basically it's my band name. Okay, and I already use here the square bracket. Okay, so that's why I simply copy this variable name. There is no problem because this things is already stored in here. Okay, simply copy and paste. Okay, so now further remove that, and now simply print this model. What you can get from here, you can see model, click run. Okay, in this time we can get the classifier train. Click on here, we can get this type of things. You can see classifier input properties mainly 10. In this time 10 bands I want to use as the input properties for classification. So in this time you can see all of those band B2, B3. So basically this type of band I want to use in here in this time as the input properties in this classifier. And I put the number of trees 150, randomly I put it. And in this time, suppose I want to put the one thing, suppose plain. So now we can get the more information about this algorithm. Here you can total 5 properties. Here you can see the mainly classes is the 0, 1, 2, 3. Mainly 0 is for water, then barrel length, vegetation and build up area. Importance, mainly 10 properties I want to use in here. And you can see this type of value about that. And number of trees, I choose here the number of trees mainly 150. Out of bag error estimate 0.1. You can see the trees, and here you can see there are a lot of things in here. And basically in this time it create the trees. Okay, basically number of random forest, how it will work. So just I show you that one example. Suppose random forest, basically it's a lot of statistical part for the random forest algorithm, how it will be work. Okay, so these are things. So I show you now normal example. Suppose here you can see one picture in here. Yeah, so here you can see random forest simplified. In this time mainly random forest, it create the some trees. Okay, so this of trees it create, and number of trees basically when I put here the 150, then it create the 150 number of trees. Okay, so it's the number decision number of trees 150. In this time my algorithm, it create the 150 trees, this type of tree, 1 tree, 2 tree, 3, and up to 150. Okay, and then further create this type of decision trees. Suppose in this time here you can see it create this type of decision trees. Click on here. Here you can see b3 greater than equal 0.89. Also you can some value about the b3 less than. So in this time it creates some decision. Okay, suppose in this time, suppose it create this type of decision trees and find out. Suppose it's a vegetation. It's a vegetation. It's a water body. Okay, then find out the majority voting. Okay, suppose I can get the two time. Suppose I get the two time decision. I can get the two time vegetation. So then this final class will be vegetation. Okay, so in this time when I put here the 150, then it create the 150 trees and then find out the what's the majority voting and take this class. So basically it's work look like this way. So that's why in this time it also create this type of trees. You can see lot of trees or decision trees it's create, mainly 150 we can get from here. You can see 149. So basically it will be start from the zero, from 0 to 149, total 150. Okay, so now we can get about this model. So in this time, this model I want to use